Good morning, everyone. Today, let me take you through the webinar of Integrate Electrical and Mechanical Product Designs with SolidWorks Electrical. My name is GopinadhKVNSN. I'm a technical manager for SolidWorks Electrical and PCB India. So before going to the actual discussion of integrating electrical and mechanical product designs with SolidWorks Electrical, let me introduce myself. So as I explained, this is GopinadhKVNSN. I'm a technical manager for SolidWorks Electrical India. So with regard to my experience, I've got around 16 plus years of experience in industry and 11 years of design and manufacturing companies like Marine and rolling stock at rail transportation, etc. And I had been with SolidWorks community since February 2015, and my expertise is around on SolidWorks Electrical. Okay, let me show you the agenda of today's web session. So we'll start with an electrical design process, and I'll take you through the typical electrical design challenges where the industry, the electrical manufacturers which typically come across, and why a SolidWorks electrical solution is required to resolve the industry-related electrical design challenges. That's what we are going to see, and we'll have a brief product overview, and we'll have customer references and engineering product suite questions and answers. Okay, so let us see what is there in the industry today. So as we see, so we will be visiting the most of the customers, and we understand that as we have engaged with hundreds of companies and found that typically the electrical harness design is a completed and a serial process. So it might be starting with an electrical definition, that is an electrical and the hydraulic or a pneumatic schematic definition using the symbols, the symbol libraries, the cables and data, and then it will take us through the mechanical design process. So the inputs from the electrical department will be given to the mechanical design, and then they will take it across to the mechanical design team. So the mechanical designers develop the project in electrical SolidWorks 3D CAD, but have very little knowledge about the physical requirements of the electrical aspects, such as harness definitions or the connectors database and the best routing path definition, etc. So any signal segregation must be observed before they actually put the components and then lay down the routing path. So once the mechanical design is far enough, you have to accurately integrate the electrical aspects into the design requires building a non-functional mock-up for a physical prototype to be developed. So many of the customers reports that the ball of the string and measuring tape, the most prevalent tools which they normally use it for using these things. So when the mechanical design comes in, and then they used to do it with the SolidWorks 3D CAD, and then the integration starts. So as I explained, most of the people will be still using kind of a measuring tape or the other measures to measure the actual length of the cables and all. The final documentation like bill of material and other aspects, device and then cable lists will be coming as a final documentation process. Then it will take you through the operations, then the production will come. The manufacturing and the production will commence. So this is a kind of a serial process where one process, the mechanical design process, is waiting for electrical, or electrical design process is waiting for the mechanical inputs. So either way. So let us see what is an enhanced electrical design process actually reflects for us. So it explains that the electrical engineers do the schematic definition, and the schematics has been built, mechanical design. So we will see that in the parallel process, schematic definition and the mechanical design can be done in parallel, and then integration can at later part of it. Final documentation, and then the quality check, purchase and everything has been completed, and then it can push it on to the manufacturing related activities. So thereby we're actually reducing the number of process steps to streamline our process, to reduce the time, as we all understand the time is money. So we are actually saving a lot of money, number of iterations, and then we are also initiating and efficiently utilizing the capability of the resources which are available at the factory premises. Okay, so What are the typical design challenges in the electrical? So let us discuss on this. So most of the designs which we see here in today's world are the manual drawings. That means the symbols created like blocks, the drawings created like a manual drawings, all the text or the specification, definition, all the schematic will be defined as a manual entries only. And the general arrangement drawings. One is the schematic and the general arrangement. So this is where the most of the problems or issues will occur. Symbols and parts. So symbols and parts are the critical and very important features for a schematic definition. This is the heart of a design. So all these symbols which you are seeing, whether an IEC or ANSYS symbol standards, for a typical electrical schematic can be defined manually, and which is a challenge because there could be a chance for the duplications. Then comes the PLC and terminal list. So most of the electrical engineers knows that how a PLC can be configured with an input or an output modules with the input devices which is connected to the PLC, or the output devices which are which is driven from the PLC outputs. Either can be relays or a solenoid valve, whatsoever it is. So all these manual preparation will lead to an erroneous outputs. This is a typical design challenge today. So you can see it on the right hand side of my screen, the terminal list. There's so much data manually need to be interpreted for preparing this kind of a terminal strip drawing. Fine. Next comes the wiring harness wastages. So as the manual preparation goes on, for a typical and then critical electrical schematic package which is having a 30 or 40 sheets, having number of cables or wires which are running throughout the schematic package, so there comes the duplication of wire numbers, the customization or repetition of the device tags, etc., etc. So due to various these reasons, wiring duplications might occur, the shortage of the wires when actually the wires are just getting connected inside the control equipment. It leads to a huge wire wastages. As we all know, the wire bundles, wiring can be ordered as a bundles. That's what the many of the manufacturers will do. And BOM, the bill of material, bill of quantity is also another name for this. To prepare the bill of material, segregated as per the manufacturer or a consolidated sheet, one has to refer all the schematic and the number of elements, what are the manufacturers, what are the part number, how many quantity it has been used, and what is the description it has been associated, which location it has been, what is an item code. So all these typical specification of the components has to be reflected on a manual basis to a bill of material table. If any error occurs, or if the user commits any mistakes in that phase, it can't be recovered, and the duplication occurs if instead of one, if he mistakenly has just added 11 for a particular component, the purchase guy will order for 11 elements instead of one particular item. So this leads to huge based upon the cost of the component which he has ordered. Impact on the costing part of it. Ultimately, we'll be getting the delay will happen in the project, and we are missing the customer's consensus. Confidence. Collaboration. So as we see, the collaboration between the electrical and the mechanical systems or divisions or the teams is the biggest challenge in the electrical industry today. Most of the teams in industrial scenarios, so they will be working separately or isolated in the world. So electrical design will be completed and then giving the outputs to the mechanical, and then mechanical has to do the changes as per them, or maybe they will be just coming over a table, having a discussion or fighting all these things. So the collaboration is an issue, typical industry issue. Quality, yes. It is going to be a really panic situation for the quality testing engineer or quality assurance engineer who's working on an electrical system, having a duplication errors in the wiring or a cabling, or might be the device stacks which he used. So he need to again identify all these errors out of a package of 40 schematics, and then he need to send it back to the design team for a re-verification, revalidation. So the number of iterations, if it is increases, that badly affects the quality. So this is another very critical design challenge for electrical systems. And all these above items will lead to a project, increase the project cost, and obviously we are not able to meet the project deadlines or timelines, and the customer losing the customer confidence on our capability and the delivery commitments. Fine. Now we'll see why a SOLIDWORKS Electrical is required. SOLIDWORKS Electrical is an automated software, so which helps the electrical designers in the industry with an automated symbols and automated creation of the wiring diagrams and the schematics and the bill of material and other reports to reduce their design time, design cycle time, and then to eliminate the errors to faster completing of the project process. A quick and easy single line diagram, schematic, and then general arrangement drawing creation. So you can see on my screen, so this is a multi-line schematic and this is a general arrangement drawing. And SOLIDWORKS Electrical supports with a comprehensive content library. The content library in SOLIDWORKS Electrical is the heart of the SOLIDWORKS Electrical package system. This is heart of every automation software. So using a comprehensive content library which is having the symbols, so we have got a symbols manager, 2D footprints manager, or the title blocks manager, and the macros manager, and the cable references manager, and the manufacturing parts manager. So we can also create a different specific library for a specific need. So specific symbols for single line, multi-line, and 3D part and assembly level parts, as well as the 2D footprints can be associated for a manufacturer, so that when we are in a single line diagram or in a multi-line or in the cabinet layout, we can readily insert the relevant symbols into type of a schematic. Using SOLIDWORKS Electrical, the powerful PLC and terminal strip generation can be generated. So we can have an automated PLC linking with the input-output modules or the input-output symbols, and PLCs can be automated. All the PLC symbols, various configurations based upon various number of manufacturers can be added onto the schematic space automatically and then linked with the macros which are running inside our macro manager in SOLIDWORKS Electrical to link up to the PLCs as an input or output modules. Terminal strip generations. Once we have had terminal strips, we have seen in the previous slide that how a terminal strip generation is tedious and cumbersome process to get the details or reflect the details which has been associated with the terminals in the schematic package. A terminal strip with this complexity, this much complexity, will take a hell lot of time for the designers. To reduce that time, SOLIDWORKS Electrical has come across automatic terminal strip generation once the terminal has been configured well on the schematic page. Automatic wire and then ferrule routing can be done using SOLIDWORKS Electrical. So we don't need to add any manual wire interpretation. The system won't allow the designer to add the wires in duplication. Automatic bill of materials. So once we have all the components configured associated with the manufacturing part and all other details, symbols have been configured, then we can easily produce the automatic bill of material and then wiring reports with a single click. SOLIDWORKS Electrical will also support in bi-directional 2D, that means schematic, and the 3D integration with an add-on application called SOLIDWORKS Electrical 3D, which works as an interface between SOLIDWORKS schematic, electrical schematic, and electrical 3D. And for the quality purposes, SOLIDWORKS Electrical supports a real-time design rule checks where these rule templates will specify the designers to identify specified mistakes in terms of kind of a duplicated connection points or duplicated equipotentials, or verify the maximum number of section of the components. If we have 100 components added onto the schematics page, and we wanted to see that out of 100 components, how many of them having the manufacturing parts associated with it. So likewise, different templates, different design rules will define and identify the errors with related to the project, reducing the time of the quality engineer. And with the above tools and features, support features from SOLIDWORKS Electrical, we can easily attain our projects, complete our projects in time, and we are reaching our market, our products to the market on time to market. Okay, so let me quickly show you SOLIDWORKS Electrical data management. SOLIDWORKS Electrical at the backend supports SQL, supports SOLIDWORKS Electrical, and all the SLD, multi-line schematics, reports, and 3D panel designs. All these components, cables, database, everything created inside SOLIDWORKS Electrical will be supported at the backend with an SQL server. Okay, let us quickly see what we have today on SOLIDWORKS Electrical demo. Okay, so what do we see today? So I have just basically categorized into 4 different segments for this demonstration. The first is we'll see that how quickly we can generate this the schematic configuration, and we'll go to the terminal strip and the general arrangement drawings. We'll see the collaboration with 3D, Electrical 3D, SOLIDWORKS Electrical 3D, and we'll also see the reports and documentation. So these are the 4 segments which we are going to see on the process. So first, let us see on the schematics what are the challenges. As I already explained, simple creation then components is a tedious job. Manufacturing parts definition, as we are adding them onto the schematic manually, and wiring cable definition also manually we are doing. There is no automation involved. Manual PLC IO drawing and then terminal strip drawing creation, which any manual CAD user will be adding manually. See, these are the typical challenges on the schematic generation point of it. So let us quickly see what do we have in the schematic SOLIDWORKS pattern. So let me just take you through the schematic of SOLIDWORKS Electrical. So I'll just quickly, let me just close all these things. Okay, so on my screen you are seeing the typical single line diagram of a SOLIDWORKS Electrical. So SOLIDWORKS Electrical, as I explained, helps schematics easier and faster. So what we are looking at the SLD is a simplified representation of the cables components used in the particular project or a diagram. So I would like to take a closer look at a particular motor, and notice that it has got no inside details of manufacturing parts which is associated, and then got connected to the terminal strip. So let us just go and then see what it is. So if you see it here, this is a typical design flow, and there is from one incomer, and then which is the design flows with the individual load distributions here, and it is further taken down through a terminal strip X3, which is a notation which we use in SOLIDWORKS Electrical, and the design further keeps down to connect the motors. So we have got around there are 4 motors which is already been added into the single line diagram of SOLIDWORKS Electrical. So what do we do? So what we do is, so we will go to the multi-line. Let me just take you through the multi-line schematics. We will add a motor and the referent configuration there in multi-line schematic, and we'll come back to the single line diagram and then update this and associate, and we'll go ahead with the PLC terminal strip generation, PLCs and terminal strip generations, and bill of material, and then we'll go to the 3D, and I will demonstrate how the collaboration between the electrical 2D and then 3D can be taken place. So let me just quickly demonstrate how it can be done. So let me take you through the schematic part now. So this is a typical schematic of SOLIDWORKS Electrical. So this has got already 2 feeders, kind of a DOL starters. So there are 4 motors, as I have already shown you in single line schematic. So what I'll do is, and this has got many of the symbols has already been added to this schematic space. As you see, these are the schematic symbols. So a symbol has got a symbol properties, and all the relevant parameters has been added together, like the current rating and the residual current, and what is the description of it. So everything, and it has also been associated with a typical manufacturing part. So we can also see the properties of the manufacturing part here. and we can associate, disassociate, or reassign any other manufacturers which we have in the manufacturing parts library. So the reference is nothing but a part number in SolidWorks Electrical. So using manufacturing parts, we can also associate or assign the type of a signal, type of a the pin numbers or the circuits can be associated. Okay. So what we'll do is, we have already got the 4 motors, so let me just quickly add one more motor. So what I'm going to do is, I'm going to the schematic, I'm going to select a draw multiple schematic. So I have got, so there are wire styles to be selected. So there are 3 basic groups: electrical, hydraulic, and pneumatic. So in electrical, I have got a wiring style which is N11 and L3, that is line 1, line 2, line 3, and then a neutral, so which I'm going to select it. So we can select it any of these things, like kind of a DC voltages or kind of a AC voltage like 12, 24, 48, whatsoever. We can also create a new wiring groups as per our requirement. So I'm going to select N11 L2 L3, which is a 4-core wire, and out of which, so user has a discretion to select either all 5 of them or any of them. So I'm going to select 3 of them, and just to snap it onto this, let me just click and terminate here. So I've got all the multi-line wiring has been connected to the existing connection. So what I'll do now is, I will quickly go to the symbols. So there are various ways to insert the symbols. So this is one of the way, insert symbol, and there is one more way here for the shortcuts. People can also just type their required names, like if they wanted to add a 3-pole circuit breaker, they just type the 3 poles, so that will be reflected here, so they can easily select whichever the component which they wanted to add it on. So they just quickly drag and drop onto this, and then they can have it. Okay, so what I'll do is, now I'm going to the regular process, the actual process. I'm going here, adding the power contact. So I need to add a power contact for this. So this is a classification of these symbols. So you can see it here. So we have a classification like the boxes, cabinets, circuit breakers, capacitors, resistors, contactors, relays, so on and so on, detectors, sensors, starters, switches, terminals, transformers, like that. So let me go to the, so this is the coils. We can also have the contactors. So I'm going here and selecting the 3 poles contact. So let me just quickly select it and just place it onto this. So you can see it will be easily snap it onto the schematic space. Okay, so what I'll do is, this I don't want to be K6, so I just wanted to make it as K3. So let me just check whether K3 is available. Yes. So once the K3 is available, that's what our software searches for it. If the component, any contact or the coil, if it is already been added in any part of the schematic, we can just associate it with it, because we are going to add the power contacts. So power contact is a part of a power contactor, which is having a coil and then supportive NO&C contacts. So I'm going to relate or associate with the relay which has been there in the other page. Let me say OK on this. So it has got all the properties. What are the properties? So let me just quickly go to the symbol properties. So when I go here, so it has got the telemechanic, and the reference number is LC7K12105M7, and then which is relay of a 3 volts silent coil, which is 12 amps. So this is because we have already defined the manufacturing part number in the coil, so it has taken all the references from there. Fine. Let me just go and then quickly add the motor. So I'm going here and selecting the motor, and I'm going to, let us just check it. What kind of a motor we are going to select this motor. So when I just select this motor and snap it on, so what I'll do is, I will take motor M3. Say OK on this. So this has taken M3. So what is missing here? There is one more wire which is missing here. So what I'll do is, I will just take the same line, and I am just switching on the protection line now. Click on the protection line from the same wire style, click and then connect it. So now I have the protection line also being connected here. So what is remaining here? So I need to add the terminal strips. Let me go to the terminal strip. I can insert a single terminal strip or a multiple terminal strips. Let me select this terminal strip here, and I'm going to associate this with X1, X3 because X3 terminal strip already has been light for all the motors, so I just wanted to run M3 also from the same terminal strip X3. So let me just search where is X3. So let me just associate the X3 as per that. So let me just go here, main electrical closet, the base plate. So this is X3 for motors. And I will say OK to all terminals. And you see the wonder. So as I see, I have just added these things, all these 4 terminals, and it has taken the consecutive number after 8. So if you see, X3 is having 5, 6, 7, 8 is the terminal numbers, and once I have associated all these 4 terminals to X3 terminal strip, it has automatically taken the numbering of the 4 terminals as 9, 10, 11, 12. So so we need to associate the manufacturing part now for these 4 terminals. So let us see what is the manufacturing part for the other elements. So let me go to the component properties. So it is Antrolec 010500220. So we'll just go here to the components tab. We have the components tab. So all the components with relevant to the particular location can be clubbed together inside the components tab here. So let us see where exactly our X3 is located. So this is X3 terminal strip, and what are our terminal numbers? 9, 10, 11, 12. So these are 9, 10, 11, 12 are our terminal numbers. So I just wanted to associate a manufacturing part for this. So I can have a different part numbers here. You can see starting from ABB, Allen Bradley, Amphenol, Busman, Eaton, Electromagnetic, Entrolec, like that. So even Siemens, Hoffman, Legrand, Leary Sommer, like that. All the major contributors, Mitsubishi and all, is there in our this one, SolidWorks Electrical. So let me just select Entrolec because the other elements are also Entrolec. So let me select Entrolec, and this is the part number which I have to select. So I've selected this part number here. Let us just check quickly whether part number has been associated. Yes, the part number has been associated. What are the properties? So this is Entrolec terminal strips base, and which is having the width, height, and then all the manufacturing database related information will be populated into the manufacturing part information. So this is a terminal strip. Fine. Let me say OK on this. Quickly check this one also. Yes. We are pretty much done on this schematic page. So we have added one more DeWalt starter, which is having one contactor which is associated, and added the motor. So motor, we need to add the part number. So let us go to the motor's part number. So here, so motor is having, there are 4 UVWM, there are 4 terminals. So let us search, and now out of this, so I'll be selecting the Leary Sommer. Let me select this, and I'm going to select a 4-pole one for this motor. Okay, so once I have selected these things, so let me just select this, the 4-pole one, and close. Say OK on this. So this has got the manufacturing part information associated. Now what will it do is, from terminals to the motor, normally as we know, most of the times it will be the cable which is running in it. So what we'll do is, I will go and associate a cable course for this. Okay, so what I'll do is, I will just apply these filters, remove these filters, so that I will have a list of cables which is available. So you can see that these are the reserved cables for the project which I have just associated. We can easily go and then create a cable here, new cable out of list of the cables which are available based upon the manufacturing also, like Havells, Lap, Nexen, Rismion. So we have a lot of Siemens and T&F. So a lot of cable manufacturers are there. We just need to quickly select and then close it. So we can add the cable also like this. So let me just select W3. As you see, WT has already been associated. You can see the details, like it has been highlighted, and the origin and destination points have already been associated here. And if you see W3, it's only the cable which is vacant and which has not been assigned. There is no origin destination point. So we can quickly select this cable and the 4 wires which we wanted to convert as a cable, and I just wanted to associate the cables. Okay, so let me just select this once, say OK on this. Okay, so we have got a cable which has already been associated with it. So this has got the cable no number also which has been taken here. So you can see that this is the W3 which we have associated here. Okay, so what I'll do is now let me just zoom this configuration, save it. Let us quickly go back to the. So what we have seen here is a typical single line diagram, multi-line schematic, and then PLCs which we are going to see. And what are the benefits? Symbols and components can be created from the libraries associated with the parts from the symbols. Automatic wire and cabling numbering can be done, and then PLC layout creation can also be done automatically. So once we have done here, what I'll do is I will go to the wiring line diagram, and I will quickly, so we can go to the wiring line diagram symbol, or we can also quickly copy and then paste it here. So let me just take this one, and what I'll do is I will make this as M3 because we already have M3 which has been there in single line diagram. So I have got M3, and what I'll do is I quickly select the cable in single line diagram and just associate it with it. So once I have done this, you can see it, the moment that I have associated this M3 has taken all the properties which has been defined in the schematic drawing. In the schematic, we have defined all the properties for this motor M3 with the manufacturer and other information over here. Okay, the same properties in single line diagram, it has been taken. Let us see what is there in the cabling diagram. So when I just click on the cabling, this is not just a wire, and we don't need to write anything on this because it automatically populates everything. So once I have this, you can see it left side, it is this cable W3 motor for central conveyor rail of so-and-so specification, that is 1000 R2B RH 4G 1.5, which is running, which is having the cores like brown, black, blue, and then green. There are four cable cores of so-and-so 4G into 1.5 square mm cable connecting between X3 motors and M3. These are the terminals. So when I click this, you can see it where exactly this is getting connected. It will be highlighting. You can see it on the left hand side. It is getting highlighted with an yellow color. Similarly, if I just click on this cable terminal, so where exactly this is connecting? This is connecting on the motor side M. This is connecting on the motor side V. This is also connecting the motor side U. So this is how intelligent the detailed cabling will be connecting. We don't need to produce any kind of a specific wiring diagrams. If we want, we can also create it, but this cabling diagram, the detailed cabling, will give us plenty of information for us to see that how a cable and then cores has been connected to the source and then origin and then destination components. Close. I would like to just close on this. So you can also display some of the hidden features on this. So this is how, similar way, we can also associate or add number of single line diagram symbols onto the single line diagram space. What we'll quickly go to the schematic space again. Now, so we have got the schematic almost done. So we just need to associate couple of origin destination points. I will go to the schematic. As you see, this is a single line transformer which is converting 230 volts to 20 volts AC. So this is feeding the 20 volts AC supply to the PLCs, whether input or output modules. So PLCs will be taking the 20 volts AC from this transformer, and it will be distributed further for the all other power supply points in the schematic package. Okay, so how do we connect this? So there is a specific way to automate this process in SOLIDWORKS Electrical. So let me just show you how we can connect it. So there is, say, origin destination arrows. While clicking this, so I can have this, the left hand diagram to be connected and the diagram where it need to be connected on the other page. So we can also go to the previous pages in this and then quickly select which the origin and then destination points. Okay, what I'll do is now I'll be selecting a single insertion here and selecting the phase of this 24 volts AC, and it automatically takes in identifying the red phase. Even though if I'm taking my cursor on the green, it won't be able to connect. It won't connect because it actually catches the equipotential point or voltage which is being used. We know the transformer, when it is phase and neutral, the 24 volts AC, that phase will be connecting only with the phase. So that kind of an automation and the advantage is there with the SolidWorks Electrical. So let me just collect this. And now I'll be connecting the blue, that is a neutral point, with the other neutral point as a supply to the PLC in the other page. Another page. So let me just quickly close these things, and then we'll see what exactly this connection reflects for us. So let me just quickly say that, so we can navigate using SolidWorks Electrical origin destination points. How do we do that? So let me just right click, go to destination arrow. It leads us to the destination page, and this, which is page number 6, and which has got the reference of page number 5 and then column reference. So it can be column or a row reference, or a column and row reference. It can be either way. So it can be customized using project properties, project configurations. So project configurations are the one where every configuration has to be formulated, whether it's a PLC or a PLC signals. So we have got the formula manager for every configuration in SolidWorks Electrical, which we are doing it. So we have got a mathematical function, texting functions, and then various other functions can be used to automate our process as per the customized need of a customers. So using the project configurations, which can easily define the origin, destination, and all other control cable references. So let us just go back to the origin arrow. Yes, it is taking us to the origin arrow again. Okay, so let me just save this configuration, and let me go to the terminal strips, because we have already added the terminal strips which is required. So these many number of terminal strips which I have used in this. But if we wanted to publish the terminal strips, so we can just select this, and we can say that this has to be propagated and this has to be drawn. If any other terminal strip which we wanted to do it, so that can also be selected and then generated. We can reorder the terminal strips. We can keep reorder the terminal strip as per our requirement. We can edit the terminal strip. So edit terminal strip will gives us the information about the number of terminals, and about the earth terminals, the cables and the destination point from where it is coming, and what type of terminal, what is the manufacturing part, the cable associated, and the destination where exactly it is connecting it. So it is clearly saying that W1, W2, W4, and then there is one more W3 which is connecting from 9, 10, 11, 12 and all. So we can also go to the terminal properties, change the properties, and then come back. Let me select X3 and generate the drawings. You can see it how beautifully we can generate these cable drawings using our SolidWorks Electrical strip. Okay, so this has been generated. So let me just close and go to the tab, and you can see it here. So this is a terminal strip generated automatically using SolidWorks Electrical. So you can see it. There are 1, 2, 3, 4. This is the fourth is a earth terminal or a protection terminal which is being connected with a cable W1 with the specification 1000 R2B RH 4G10. And these are the core of the cables, brown, black, blue, where exactly this is getting connected. M1 motor, UVWM, and for the motor end also you will see the cable core information with the motor details of it. What is the location, who is the manufacturer liaisoner, what is the part number, LS 101 and L4P3, all these information, what is the capacity of the motor, everything will be reflected in the terminal strip with a single click. And then you can imagine that when we do manually to produce this kind of a complex terminal strip, it will take hours together for the designer, and it also error prone. So let me just close this one. I will quickly now show you how to generate the PLC drawings automatically. So we have already seen here the PLCs which has been associated. PLC drawings can be created easily using SolidWorks Electrical with connecting the inputs and outputs as per the input-output modules which is being connected together. So what we'll do now is we will automatically create a PLC. Let me just show you. I will click on the project. I'm going to PLC manufacturing part, and I can quickly select any of these things. So let me just select Schneider Electric for the PLCs. This is the category. And let me select SR3B261B, which is 24 IO, 24 volts AC. Let me select quickly, select this, and on N2, so I have got I1 to IG are inputs and Q1 to QA are the output points. So let me just select these some 10 inputs. Okay, so you can select all of them. I just quickly show you how you can do it. I'm going to add a new PLC input outputs, and what I'll do is I wanted to associate for the a macro for this PLC symbol. So let me just click on this. I'm going to select a macro. Macro in SOLIDWORKS Electrical is, it's not a coding, but it's a symbol or a group of symbols linked together to be used for a design reuse. Okay, so what I'll do is I will go to the PLC record. So I'm going to add this macro, that is a symbol which has been linked to the PLC input symbols. Similarly, I'm going to select Q1 to Q7 and I'm going to add new PLCs. Click on this, select a macro, and what I'm going to do is I'm going to connect these things from bottom. A coil I'm going to connect from the bottom. Yes. So what I'll do is, now let us quickly go back and see how effectively we can add these things automatically. Fine. I'm going to the components tab and let me select this and I'm going to generate PLC drawings. So where exactly? In this pattern. So let me select this. So let us see how quickly it can generate the drawing. The PLC drawings can be automated and then generated automatically. Yes, so N2 PLC drawings has been generated. So let us quickly see, is it generated automatically? Yes. So let us see it. The PLC drawings has been generated. You can see it. The output drawings also being created. Okay, fine. So this is how the input output drawings can be created using PLCs. Let me just quickly close these things and close this one. Okay, so we have pretty much done on the schematic side. Let us go back to the PPT. So as we have seen, the challenges as I discussed, manual terminal details, assignment of the cable details, creating a 2D footprints for the GA is also a challenge for this. And this is a terminal strip as I have already explained, and the terminal strip which has been generated, and this is a cabinet layout. Okay, so we will see now on the collaboration part. So how the design collaboration using SOLIDWORKS Electrical and Electrical 3D can be done. So it can be done using a discrete 2D 3D design. These are the challenges. And cabinet sizing and configurations. So it is very difficult and error prone for the designers to decide on the cabinet sizing and the configuration. Routing. When we are doing a routing, it's always been a manual routing. It is just laying down the cables or wires from one point to the other point. It's always been manual. There is no automated routing or a manual routing. And the wire cabling wastages are more here. Let me quickly take you through SOLIDWORKS Electrical demonstration. Okay. I'm going to open now SOLIDWORKS Mechanical CAD to show you how the same project can be visualized and connected, integrated, and collaborated well using SOLIDWORKS Electrical 3D application, which is an interface, which is an add-on to a SOLIDWORKS platform, 3D CAD. So here, as you see, the project name is Demo Simple 2 SOLIDWORKS Electrical. So the same project which we are going to execute using SOLIDWORKS. Okay, so this is Demo Simple 2, and using Electrical 3D application, SOLIDWORKS Electrical will have an interface, will be connecting to the 3D and adding the components into it. So let me quickly show you how we can add the components onto the SOLIDWORKS 3D. So this is Electrical 3D. We are in the 3D space now. I'm going to add the same components which we have used in schematic part. Okay, so let me just quickly add K1 to K5. So these are the components. Where we are going to add? We are going to add onto this DIN rail. So you can see it. This is a DIN rail. So let me just put it onto the front view, and I'm going to insert these components. So you can change the order, insertion order, either if you wanted to have the K5 to be up or down, so we can do it at the bottom. So currently I'm not adding anything, so we can do it. So let me just add this one here, and this is going to ask me that all other 4 contactors, how do you want it to arrange? So I can arrange on the right side of the screen. So let me I can give a space of 5 mm between these and say OK on this. So all the 4 or 5 contactors which I have just associated, so we'll be taking that reference from the edge, from the right hand edge of this component, and it has been automatically added up. Okay, now I have added. So this is the beauty of SolidWorks Electrical. All these components are the similar components K1 to K5 of the contactors, power contactors used in our design in SolidWorks Electrical. So the same project components, same project data we are able to access and do the routing automatically. So again, so what I'll do is now I'm going to associate the insert X3 components. I will insert these components here. Let me just insert these components somewhere here, and it is going to ask me all these components, do you want to insert any space between the components? Currently for terminal strips, normally as you are all aware that no, we don't require any space because these are not very stable. It might fall down no, while connecting. So I don't give any space here. So let me just say OK on this. By saying OK, so it is going to add all the relevant components onto the right hand side space of the on the DIN rail. Once this process is completed, I will show you how quickly we can route the wires onto this space. So this has got all the terminals which has been used in our schematic design has been added onto the schema in the 3D space. So we can just easily move the DIN rail behind this because some components out of DIN rail. Okay, so let us quickly see using SolidWorks Electrical 3D how do we automate the process of routing. So in routing we have got routing wires. We can route the wires inside the cabinet. We can route the harnesses for any kind of an electronic enclosure or the automotive related harnesses which are running. So we can use the harness application using route harnesses. We can also route the cables which are connecting from the cabinet to motors or any other solenoid and other loads which are kept in the factory premises. Okay, so I'm going to use route wires with the specified parameters. I have routing parameters can be defined and altered, and first access connection and all other parameters. So I have some routing parameters which has been selected. So I'm going to select all the components using 3D sketch route. We can also do a SolidWorks route which is having a graphical information basically. So let me just quickly do a routing. So I have inserted the components. Now we will automate the process by automatic routing. So it is just reading all the wires. SolidWorks Electrical has got an algorithm which runs at the behind, which reads all the data from Electrical 2D and associate all the component 3D parts in Electrical 3D and route it automatically. So this algorithm is patented from SolidWorks Electrical, and which automates this process, reading all the counterpart for the schematics, and it will route it. So now currently it is just collecting all the information from the schematic and adding the routing onto the 3D space. Okay, so we can quickly see that now all the relevant wires which is already been laid down in 2D space. As we all know, how this is possible. So most of the times, no, this routing, automatic routing cannot be done. It can only be done manually using the from to list, and we need to identify in SolidWorks 3D about the components, source and the destination. So once this process is done, the wires can be connected, identifying the source component, and then pin can be connected to the destination components. So this is how normally it will be done. But using SolidWorks Electrical routing wires or routing harnesses or routing cables, we can easily route the cables and connect the components as desired, as required, defined in the schematic package. So in the schematics, we have got like from the circuit breaker to the power contactor to the terminals to the terminal strips, and all these things which we have already seen it. So those things can be taken together. So this is how normally we can do the routing part of it in SolidWorks Electrical. So let me just say okay on this, save it, save all. And we can also change the parameters, routing parameters, to automate these things. So we have chosen little less routing paths. So let us quickly take a quicker routing path, route wires. So let us change this to something around 500 and see that what is the routing length, how it is going to be affected. So let me just take this, continue, and deleting the existing route. So what it does is basically, so it because we have taken the lower routing widths, so because of that it has taken the very shortest distance to connect the components, optimized connecting to the components. So that has led to shortening of the wires, and the wires are run randomly. So what we are doing now is to correct the problem of routing. Because if the wires are routing in a different fashion like this and crossing and not following the path, so it will not look good. So it has to take the routing path as defined inside the ducts which we are placing it, and it has to follow the path which we have defined it. So SolidWorks Electrical will correct all these limits with the routing points which has been associated with it. So all the components which we are seeing it in 3D space here are the same components which we have used in SolidWorks Electrical 2D, that is in the schematic space. So in the schematic we have defined 100 components, and all the 100 components relevant 3D parts will be reflecting in Electrical 3D. Using that, we just need to associate those components in 3D and add the connection points, because for electrical connections the connection points are the basis to do the routing. Connection points are the basis to do the routing, because rest everything is a SolidWorks part. Okay, so let us see what we have. So you can see it now. All the connections have been corrected. So I have just shown you, if we don't put the parameters correctly or rightly defined in the route parameters in the routing wires inside the cabinets, how the routing can be and how it can be corrected with the right routing parameters. If you just observe, so I have put it like 120 is the space between the connection point and the first routing path. If the connection point and the routing path is very less, so it has taken the very short distance and then it is routed randomly. So that has been corrected with the right routing parameters, has been inserted and then rerouted the path again. So this is how the SolidWorks Electrical routing can be used, automated, to route the cables or wires automatically. Let me just save this configuration for this moment, and I will quickly show you how effectively the routing cabling also can be done effectively using SolidWorks Electrical in a bigger space. So let me just close this, and we can see it in the field location array. So this is the master assembly, where we have got all of the conveyors and the blister packing machine and the conveyors. So we can see it. So the packaging machine, this is the packaging machine, and which has got a control panel which is controlling the activity of the motors and all. So what we do now is we'll just quickly route the cables to the motors which is being associated outside. So what we'll do is we will just go to the route cables. Before that, let us just quickly see whether all the motors have been identified, associated. So this motor has been associated. This is identified as an M1 and this is identified as an M2. So where is that M2? So you can see it here in 3D space. This is motor M2, and we have got another two motors which is M4 and M5. Okay, currently we have got three. So what we'll do is we will quickly run the cabling part of it and see that how it can be associated. Right. Let me go to the route cables, and I'm going to use SOLIDWORKS route, and let this be there, distance between this, and I'm going to select the components like motor 1, and let me just select this motor also, this motor also. So likewise the other motor currently we are not considering it. And yes, let me just do the routing part of it. Okay, let us quickly see that how routing can be associated. Let me just put this on. I will go to the route cables, and I'm going to select the components here, 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 and this, the four of them. Before that, let me just show you on the origin and destination, do we have all the windings have been done or not. Let me select this. Yes, this has been associated with the cabling. So W1 is there, W2, let me check the W2. Yes, the second gland has been identified and second motor has been identified. Let me quickly go and then see W4. Yes, this has got the details, and W5, this is also okay. This doesn't have the detail of it, so we can associate this one here with this one. Close this, and what I'll do is route cables. I'm going to select the components now. One, this one, third motor, and the fourth one. I'm going to make it as 300 here and do the 3D sketch for the selected components. Yeah, let me do the route cabling. So it is going to do the route cabling. So as we see, so by the time it does the cabling, we'll just come back to the PPT. So on the design collaboration, what we have seen is the routing inside the control cabinet like this, as you see on my screen, and then cabling part of it to the equipment or motors which has been connected it. So now we will also see different documentation and reports. What are the benefits of the design collaboration is bi-directional 2D and 3D integration. That's what we have seen. From 2D we have defined everything, and then the same components as a parts which has been associated in 3D, and we are able to do 1:1 configuration of the routing and then cabinet spacing, everything. Auto routing also is possible in SOLIDWORKS Electrical 3D, and we can also estimate the exact cable length to eliminate the wastages, the wiring wastages. Okay, so next comes the documentation reports, the final chapter of our demonstration today. What do we see here is wire numbering. What are the typical challenges in the documentation? Wire numbering and the duplications, device tabling and the duplications, bill of material manual entries and then kind of duplications, unable to segregate the bill of material as per the manufacturers, or wire cut lists and then connection tables. To prepare this manually, we are preparing it. Design quality is greatly impacted on committing kind of mistakes in wire numbering or a device tagging or a bill of material or a wire cut list. So these are the typical challenges. And what do we see? Let me just show you these things here. So you can see it. So once I have associated, you can see it, the wires which has been light down. So this is wiring which I have just taken it. So this wire, when I click it, so this has been connected with the motor, this cable, and this has got a 4 core. Further, it has been distributed from the cable point. This is the cable point. So till this, the cable has come and then it has been distributed into a 4 core. Similarly, the other parts of it. So there are other cables which has been connected from the control cabinet. You can see it here, and it has been done. So how it has been connected? It has been connected through the terminal strips. From the terminal strip, it has come through the gland. It has gone and then connected to all the 4 motors. You can see it. The motors have been connected well. So let us see on the 4th one also. This has been connected well with the 4 core has been distributed into the motor space. Now what we'll do is we will quickly go and produce. Let me just say OK on this. Click this. What I'll do is I will take the manufacturing drawing, the 2D cabinet drawing from this. So what I can do is, let me just say OK on this. Edit sketch. No. OK. Fine. What I'll do is I will quickly go to the assembly, electrical 3D, and create a 2D drawing from this. So users can easily create the drawings from this, 2D drawings from this. So how do we do it? So once I go to the 2D drawing space, it will ask me to create a 2D drawing based upon the template, either A0, A1, A2, A3, A4, like that. Okay, so what I'll do is here I will come here. Okay, so let me just delete the existing details of it. So I don't want these details currently. So I can just select these details because I wanted to populate these details again. Okay, and this one also I just wanted to make it. So what I'll do here is I will quickly go to the sheet and go to the sheet properties, go to the standard size. Let me select A3 size, apply sizes, and I'll be taking the A3 size here. So what I'll do is I'll be quickly drag and drop the front face of it, front view of it, and I will be making the scale. I can use a custom scale here to just make it as 1:2. So let us see 1:2 how much it is going to come. Let me just take it as 1:5, how big it is going to come. Okay, so this, let me just select this here and go to the custom scale. Let me make it as 1:10. It is going to be big, so you can easily check this whether you can make it, how big you can make it. So let me just take this one, and this has got all the details of the front view which we have added it. So with our cable, so all the components which has been taken here. So what I'll do is I can crop this view. I can take a single view and then I can also crop this view. So how do I do it? So I can go to the evaluate. Let me go to the sketch, view layout, and crop view. So let me go to the sketch first, and what I'll do is I will just make this like this and go to the view layout and crop the view. So I can crop the view. You can see it here. I've just cropped entire view, only retaining only the control cabinet. What I'll do is I will quickly add the annotations for this auto ballooning. So auto ballooning has been done quickly and easily. Say OK on this, and again I'm going to select tables, bill of material. So standard bill of material, standard parts and all, top level only. Say OK on this. So if you have selected top level, it is only giving the top level only. If not, we can also select this, and electromechanical bomb, we can select it. Go to the bill of material, parts only, intended. Let me just check here and add the components. So you can see all the relevant bill of materials has been added together here. So this is how you can also split the control the bill of material from here using split bill of material. So I can just have a right click, split horizontally. So it will say that how do you want it to make it, like 2, 3, 4, and apply. So all these has been added together like a 4 or 5 tables. So we can quickly arrange these things over here to complete the bill of materials. So this is how quickly we can generate the different views of 2D cabinet layout can be automatically created from 3D, and then bill of material, combined bill of material for electromechanical systems can be created. So once we have done this, let me just save this and go to the electrical drawing, create a project drawing so that it will be appended to the project tree. Has been successfully added. Let me just close this one so we can see it in SOLIDWORKS Electrical. So it will be created automatically to the 2D cabinet layout. Fine. This is how we can do the automatic routing, cabling to the 3D space using SOLIDWORKS Electrical. Let us quickly conclude our session with reports. So we will go back to the documentation reports using SOLIDWORKS Electrical. So we have done to the end of the discussion. I'm going to take you through the project reports, and let me quickly select, so we can select the various report sections here. So let me just select bill of material grouped by manufacturing number and reference per book. Let me just select these things, say OK on this. All these templates have been there, so I can quickly generate the drawings. Let me select all of them, right? Say OK on this. So you can see it, all the relevant reports, bill of materials, wiring tables, cables, lines by wire style, or the device tag list. So everything can be added into the schematic tree and appended to the project tree. We can also add and link the project documents here. So you can see it, list of bill of materials. So you can see it as per the manufacturer. It has been segregated because that is the template which we have used, like grant and all other aspects of it, layer somewhere. So these are the reference, description, number of quantity, and mark. So list of cables. Let us see what is there on the list of cables. So these are the list of cables, description of the cables. The first cable is motor for load conveyor, second is for the motor for central conveyor for rail, third is for unload conveyor. So likewise the location path and length of the cables which has been run. If you remember, we have run 2 or 3 cables there in 3D space. So all these, how much length it has been, the length can be calculated using the length reference. And then type of the cable, who is the manufacturer. So everything can be reflected in the cables data as well. And we also have the drawing list can be populated automatically. So this is how we can automate the required elements in SOLIDWORKS Electrical. So let us quickly see how we can automatically generate the single line diagram, multi-line schematic, and PLC drawings, as well as the control cabinet layout using XLS automation. So let me just quickly go to the import export options, go to the XLS automation, and link an Excel file. So let me just show you how I can configure this XLS automation. So I have an Excel sheet where it need to be configured, linked with the macros, list of macros. So as you see, for XLS automation, so user has to configure the XLS sheet with the device data, manufacturing part numbers, and the macro references. So I have got, so this is the macro reference table where I have a different macros. So as I said, macro is a single symbol or a group of symbols associated with the manufacturing parts linked together with any kind of an automation process. And so I have got a macro position like X and Y. So I need to just add the X and Y coordinates where these macro symbols will be reflecting onto the schematic space. So I need to basically identify, if I just go to schematic and if I open the schematic, so I need to identify where exactly this vertical stretch is going to be added in the schematic. So this, if I just identify this point, click here, 95 to 65. At the down you can see it 85 to 30. So that is the XY coordinates points which need to be mapped for these macros. As I said, we have got different libraries: symbols manager, 2D footprints manager, and then title blocks manager. Similarly, macros managers. So macro managers will have macros and symbols. So this is one symbol. This is the list of symbols associated in single macro. So these macros can be associated with the manufacturing parts and automatically generate the schematics automatically. So let me close all of them, and we'll see it. After this 67, we will also see some more schematics will automatically gets generated from XLS sheet. So let us see how we can do it. So I have got the XY coordinates for these elements to be mapped. The first one I will make it, because I've just noted down, to 265, and the other elements, like I can make it as 120 and 260. So 40 distance, 160 and 260. So likewise we can just add the components. So let me just copy. So the rest of the items from here, which I have already added into it, we can easily add it from 160. So let me just add, paste it in. So all the relevant XY coordinates has been added here together. What we'll do now is we need to associate the motor relevant details. So we have got 5, 6, 7. So I'm going to add 2 more motors, which is M8 here and M9, and I'm going to link it through the same terminal strip, and I'm going to add. You can alter the variables here. The reference variables, manufacturing variables can be altered together here. So once I have got the manufacturing and the variable for the motors has been defined inside Excel sheet, let me just save this sheet, close it. What I'll do is I will go to the import export, go to the Excel automation link, and on desktop let me go to the file with cabinet and open. Okay, so this project has been opened in the other session. Let me just close the other session which is being there in 3D. So let me just close the session here. This one I'm going to close it. This project also I'm going to close it in 3D. Let me close the 3D window also. Okay, so let us first go to the Excel automation cabinet. Yes, it's running now, because if it has already been opened, so it can't collect all the data to populate the results into the XLS automation space. So you can see it here, it is being added after 67. You can see it is being added here. So let us quickly see how it can be added and can be done. Yes, so let us see what is there in it. If I just click it, yes, so this is an automated multi-line schematic with 5 vertical feeders has been added automatically with the manufacturing details. You can see it, the manufacturing details also being populated here. Moiler, this is the manufacturing part. Let us see it here, Moiler 0990131, so which has been given for Q4. So that has been reflected in Excel sheet. So whatever the changes which we wanted to make it, we can map it in Excel sheet, and then it can be populated inside SOLIDWORKS Electrical. Let us see what is there in the second. So it has been generated, the PLC drawing has been generated automatically here with inputs associated with the PLC symbol separately. And what is the third automation output? We also got the multi-line schematic here and a single line schematic here with a similar kind of a manufacturing details. What are the manufacturing details which we have it in multi-line schematic defined? It has already been there in the single line diagram and vice versa. So all the 3 or 4 stretches which has been added here. What is there in the final output? We can also generate the control cabinet layout automatically using SolidWorks Electrical. So what is the usual way? Usually when we are doing it, so we can go to the process button and go to the 2D cabinet layout, and when we say OK on this, usually the 2D cabinet drawings can be added together. Let me just close these ones so that we will understand this. So these are the cabinet layouts can be generated inside this. So we can insert required symbols inside this space, and we can also insert particular dendrites onto the space and add the components. So this is the normal way of adding the required components inside this. But there is a specific way to generate automatic control cabinet layouts using XLS automation in SolidWorks Electrical. So this is how we can do the documentation and reports. As we see, we have produced the bill of material, and we have also seen the report configurations and the total length calculated from the 3D space, which has also been there, and then design rules manager, which is for the quality purposes. What are the benefits? Auto wire and then device numbering automatically can done. Unified bill of material, auto bill of material generations. Real-time wire list and then cut length can be calculated, and we can improve the quality with the design rule checks. So let us quickly conclude our session with a couple of slides. So what are the productivity tools for the designs? We have a productivity tools in SolidWorks Electrical for intelligent automatic single line diagrams, searchable shared libraries, and design rules kind of a thing. And then there are huge automation resources in SolidWorks Electrical, which is auto schematics from Excel sheet can be generated, PLC management, wide numbers can be automatically done, 2D, 3D connectivity, integration, collaboration can be done automatically. Collaboration bi-directional from electrical schematic to the electrical 3D can be associated and can be integrated with the 3D and routed properly, and real-time multi-user design environment can be done. We can also link the SolidWorks electrical data to the product data management PDM, which is also a enterprise PDM, which is also a product of SolidWorks, or any ERP can be linked together. We can publish e-drawings and intelligent PDFs also can be produced. Documentation. Quick and easy terminal strip drawings, bill of material from tool reports, calculation reports, and voltage drop duct fill ratios can be calculated here. So these are the SolidWorks mechatronics solutions. So planning, the first phase is SolidWorks Electrical. We do this electrical schematics, and then planning and documentation can be done. Control panel layout can be done using electrical 3D, as I have shown in my demonstration. And further, if we have any kind of a PCBs which has been associated in our design, then it can also be subjected using SolidWorks simulation software for simulation, then testing for fatigue and the flow and analysis, FE analysis, and it can link to the manufacturing virtually, and it can also be produced a documentation for a user manual or a maintenance manual for the users or technicians who are working under the factory premises. So this is a complete SolidWorks mechatronics solution for the industries. Fine, this is the SolidWorks ecosystem, where if we walk into any kind of a manufacturing industry, we will see mechanical divisions, electrical divisions, electronic divisions, purchase divisions, data management divisions, or the plastics or injection molding or a simulation. So these kind of different segments can be connected together to produce a product. So SolidWorks Electrical ecosystem reflects having a support to mechanical design using a SolidWorks 3D CAD, and we can also do a electronics PCB and the schematic design using SolidWorks PCB and another module and another license. We can also manage efficiently all our project relevant data using SQL based data management, that is enterprise PDM professional. And as I have already shown, the electrical design is also possible using SolidWorks Electrical standalone software, and it can also be integrated with SolidWorks using an add-on which is called Electrical 3D application, so that the dynamic collaboration in real time between electrical schematic and then SolidWorks can be achieved. Further, SolidWorks also supports the FES simulation, plastic part injection, and composer for the technical documentation, plastic injection simulation also as well. So these are the different products which helps the engineers at a different customer level to produce their unified product using SolidWorks products. With this, I'm concluding my session. Thanks for giving the opportunity. Thank you. Take care.